Equations and properties of lines, sample problems. In this lesson, I will show you how to solve some problems in analytic geometry under the topic of lines, properties of lines, and linear systems. So far, the tools that we had spoken about lines, tools that are pertinent to lines and the rectangular coordinate system are slope, which is change in y over change in x. Okay, parallel lines. So two lines are parallel when their slopes are equal. Perpendicular lines. Two lines are perpendicular when the product of their slopes is equal to -1. Distance between 2 points. Okay, and I forgot to write here the coordinates of your midpoint. Okay, so given 2 points, A and B, the coordinates of the midpoint, okay, let us call M to be the midpoint, is or are x sub 1 plus x sub 2 over 2, that's the x coordinate, and the y coordinate is y sub 1 plus y sub 2 over 2. So this is like you are just getting the average value or average values of the x coordinates and the y coordinates. We will also need this, okay? The equations of your line. So you have the standard form, you have the slope-intercept form, that is the slope, that is the y-intercept, the 2-point form. So when you are given 2 points, you can produce the equation of that line by using this, okay? And this, by the way, is just the slope of the line. Point slope form, okay? So if you're given a slope of the line and one point with coordinates x sub 1, y sub 1, then this is the equation of your line in slope point form or point slope form. This is the intercept form, okay? So this is your x-intercept. This is your y-intercept. This is how you write the equation for a horizontal line, and this is how you write the equation for a vertical line. So problem number 1. You have point A with coordinates -1, 4. It does not lie on line L1. And L1 is defined by this equation. X minus 2y is equal to -3. What is the equation of the line through A that is parallel to L1? Write the equation in slope-intercept form. So something like this is taking place in this problem. You have the red line, which is defined by x minus 2y, which is equal to -3, and you have a point A that is not on the line. You will draw a line that is parallel to L1 and passes through point A. Write the equation of that line in slope-intercept form. Okay? Well, we must know the slope of L1. And we can do that by writing the equation in slope-intercept form. So the slope of L1 is 1/2. So since L2 is parallel to L1, this means the slope of L2 is also 1/2. Now, the first equation that we can derive right away is the equation in slope. Okay, we already have the slope and the point. So this is going to be slope point form or point slope form. And this is the equation. Okay, y minus 4, okay, is equal to the slope. This is the slope of L2 times the quantity x minus -1. Okay? And so simplifying it and writing it in slope-intercept form, that is just equal to y is equal to 1/2 times x plus 9/2. Second problem. Point A has coordinates -1, -1. It does not lie on our line with this equation. X minus 2y is equal to -3. This is the same equation that we worked on in the first problem. What is the equation of the line through A that is perpendicular to L1? Write the equation in slope-intercept form. So this is the situation. The red line is L1. A is not in L1. That is a line that is perpendicular to L1 and passes through point A. What is the equation of that line? Okay? Well, we need to know the equation of L1, or we need to know the slope of L1. It's 1/2. So if L2 is perpendicular, okay, that means, okay, solving for M2, the product is equal to -1. The product of their slopes is -1. So that means M sub 2 is equal to negative of 1 over M sub 1. And that's going to be equal to -2. So this is the slope of L2. Look at that. Slope, okay, slope and point. Slope point form, okay? So it's going to be y plus 1 is equal to -2 times the quantity x plus 1. Write this in slope-intercept form. That is the equation of L2 in slope-intercept form. A rectangle in standard position has these vertices. Get the coordinates of the point of intersection of the diagonals. Okay? So this is your rectangle. And those are the vertices. These are the diagonals. Okay? So by sketching it, you can see right away what the point of intersection is gonna be. It's going to have an x coordinate of 1, so that is 1, and a y coordinate of 2.5. Okay. But let us say we must work it out manually without using the graph. So if you had been watching my lessons, recorded lessons, you must have seen from my previous videos that the diagonals of a rectangle bisect each other. If they bisect each other, that means they share the same midpoint. They have the same midpoints. So all we have to do is just get the midpoint of one diagonal. Okay? So again, this is how we compute for the midpoint. So we will get the we will work on the origin. Okay, so this is the origin. This is our rectangle. This is the origin, point A. Okay, that is one diagonal. This has coordinates 2, 5. This is 0, 0. So what is the midpoint of this diagonal? It's 2 plus 0 over 2. Okay, that is equal to 1. And 5 plus 0 over 2. That's 5 over 2. And so the midpoint is going to be M with coordinates 1 and 2.5. And it matches what we saw from the graph. This is the coordinates of the midpoint. A circle with radius 2 is in standard position. The central angle made by arc AB, okay, is 60 degrees. Find the equation of the line through the origin and point B. Write the equation in slope point form. The problem here is the slope because we already have the point. Okay, so maybe you are paying attention to point B and you are working. Hey, how can I get the coordinates of point B? But you don't need point B because you are already given one point. It's the origin. So we already have one point. It's the origin. But how do we know the slope of this line? Okay, so that is the challenge. Well, I hope that you can still remember your basic trigonometry, your SOHCAHTOA. You know, that point B there and the angle defines a right triangle. So that blue triangle is a right triangle wherein alpha is equal to 60 degrees. Now, maybe you can still recall from your trigonometry that the tangent of an angle of a right triangle is equal to the side opposite over the side adjacent. And if you were look at it, the side opposite is the change in y. Coming from point C going to point B, y is the change in y. And x is the change in x. Well, what this is telling you is tangent of 60 degrees is the slope of the line. Tangent of 60 degrees is equal to square root of 3. And so there we have it. Okay? Using the slope, square root of 3. Okay, this one should not be 3x. This should be square root of 3 times x. I'm sorry, okay? So using your slope point form, this is the slope, square root of 3. And the point has coordinates 0, 0. And so the equation of this line is going to be y is equal to square root of 3 times x. Line L1 is defined by this equation. Y is equal to negative 2x plus 3. Find the point in L1 that is nearest to point A. Okay, so you will look what are the points here, or what is the point in L1 that is nearest to point A. So in your mind, you are maybe drawing these line segments, okay? And from there, you can see that the point that is nearest to A would be that point, okay, in such a way that this line, okay, let's call that B, let's call that point B, is a perpendicular line or perpendicular to L1. Okay, so what is the strategy for solving this? First, we will look for a line through A that is perpendicular to Y. And then, we will look for the point of intersection. And how do you get the point of intersection of two lines? Okay, two lines that would compose a linear system. Solve the linear system. Let us find the equation of the line that is perpendicular to L1 and passing through point A. Okay, so these are the strategy for solving that. So L2, let's call it L2, the perpendicular line is or must have a slope of, okay, look at that, okay? L1 has a slope of negative 2. So from the properties of perpendicular lines, M1 times M2 should be equal to negative 1. So this means M2 is equal to 1/2. That is the slope of L2. Let us now write the equation for L2. So it's going to be, so this is slope point form, okay? Y minus negative 1 is equal to 1/2 times the quantity x minus negative 1. Let us simplify this. Let us write it in slope-intercept form. Okay, y is equal to 1/2 times x minus 1/2. Now look at this. Y is equal to this, and y is also equal to negative 2x plus 3. So we have two lines that would make a linear system. Solve for the point of intersection. Solve for x and y. Okay? So we can do that by substitution. So since y, L1 for L sub 1 is equal to, y is equal to negative 2x plus 3, and for L2, y is equal to 1/2 x minus 1/2, by substitution, okay, this is equal to this. Okay? Okay, how do you simplify this? Well, what I do when I see equations like this is I clear away the denominator. It's kind of not user-friendly to students when they see a denominator. So I will multiply it by 2. Okay, I will multiply the equation by 2. So this becomes negative 4x plus 6. 1/2 times x times 2 is x, minus 1/2 times 2 is 1. Combine similar terms, x is equal to 7/5. Okay? you can compare it with this point, and you can see here that it matches what we are seeing in the figure. What is the y coordinate? How do you get the y coordinate? Well, you can just substitute the value of x to any of the equation. Okay, so let us use this. So the y coordinate is equal to negative 2 times 7 over 5 plus 3. Okay, it is equal to 3 minus 14 over 5. And this is equal to, okay, 5 times 3 is 15, minus 14 is 1. So the y coordinate is equal to 1 over 5. The point that is nearest to A, that lies in the red line, has coordinates 1.4, okay, and 0.2.